Okay. Yes, hi everyone. I'm Peter from Gear Technologies. What we do at Gear is a platform for smart contracts, asynchronous smart contracts, and a couple of words first why it's important on Substrate, because like Substrate is a framework which allows you to build a blockchain quite fast. But imagine you are doing a Web2 application that you want to migrate into Web3 space, and if you want to like get quick feedback from the market, you don't want to build a blockchain, get a support from validators, collators. So what you want to do is quickly jump in, do Web3 logic, and then get the fast feedback from the market and adapt and evolve. So that is where smart contracts is really important, and good tooling allows you to quickly do the stuff. Just a second. Okay, yeah. So what is Gear protocol? Gear protocol, well, protocol is like overused word. It's just rules and definitions of how smart contracts should behave, how they operate, and it actually stands on the 3 pillars. Actor model, which is like proven technique, which is used in Web2 world for a long time, allows great scaling capabilities, so it has great scaling capabilities, parallelization, and you can build on this technique quite sophisticated, complex application, and also which supports great composability. Then WebAssembly, which is like the common stuff for Polkadot ecosystem, but not so common in other blockchains, like in Ethereum it's EVM, and persistent memory, a novel approach which we are using for smart contracts. I will devote some time for it also later. So let's go through each of these. Actors. So what is actors? In Gear, everything actually is actor. User is actor, contract is actor, cross-chain endpoint is actor, breach is actor. All actors communicate with each other by means of messages. So, and they do not share state. Each actor can mutate its own state only by itself. So they are independent. This gives the ability to do execution in parallel. So one actor is processing its own incoming messages in a serial way, but multiple actors can be processing messages in a parallel way. Since they are all independent, there are no clashes on state and no like state, errors related to simultaneous access to the same memory, which is like quite a common case for other approaches. What's important is that we support not synchronous message communication between actors, but asynchronous. And this is very important due to actually, even if you use messages and process them in synchronous way, it's not that much like scalable solution. Any cross-chain communication could be only asynchronous. So you cannot like wait, your contract cannot wait for reply from another chain to continue execution. It needs to free the thread, processor, whatever block to be continued. And then when you receive a message, you need to wake up the contract and it continues the logic. So actors, async actors is quite a good solution, proven in Web2 world. Just a second. Yeah. Like how they can communicate. Since everything is an actor, then user can communicate via message to program 2. Then it can communicate to another program which has been created by itself. And this is also a feature of actor model. So actors can create other actors. Then it can like send message to the breach and reply to user back. And since everything is an actor, you don't care actually what block is this, one of these blocks. So while you write the logic, you write the logic which just communicates somewhere to address with a proven payload. It can set value, different payload types, and just expect reply or just shoot the message and forget. Yeah. So we have a portal at Gear which allows to upload programs, send them messages. Actually, it looks like this. So you can see the messages which has been sent to a particular program or from it to it, and reply for the messages that have been sent to the user. But we envision that the future implementation will be in the wallet of user. Okay. And imagine the interface like this, so this will be supported soon. Programs send messages to users which they can open and reply with a particular payload. It can be like okay or not okay with the price from the order, from DEX, or it can be more sophisticated stuff, like you reply with particular values with price which you will be agree or range, and then the contract will receive this reply from the user and continue the logic to buy or sell, whatever. So whatever the logic is needed. But it's really interactive. So blockchains start to interact with the user. It's a very important concept which is currently hard to implement on other blockchains due to this interaction should be started off-chain. In our world, so we see that the contracts will be interactive and can get input from the users. Oh. What's happened? Okay. WebAssembly. Well, not much to sell, I mean, in substrate world, WebAssembly, since it's the thing which is used to host the runtime of Polkadot and all the parachains. Just a couple words why it's, we see it more important to use it for smart contracts because, well, it was designed from our point of view for this. It allows you to execute pieces of code, byte code, which can be actor, in a secure, deterministic, and like in a sandbox environment. So that's the things that we require. So it's really a standard, a more novel and standard, which is supported, of course, by Polkadot, and we wanted to choose this one, comparing to some parachains which are using EVM. Nothing bad about EVM, but like we want to use this one. There are some comparisons why it's actually what is good in EVM, what is better in WASM. I will not like focus on these details too much. If you want, you can photo, and then we can discuss like after the presentations if you want. Okay. Yeah, persistent memory. That's the novel stuff. So we see the current programming languages for smart contracts, they are domain specific, like Solidity, etc. And we want to bring the devs from Web 2 world into Web 3 space. And for this, we thought that it would be nice if a developer will not think about how the things are stored on a blockchain. They just code normal programs like in Web 2, and it will work out of the box without like accessing storage, you know, thinking about this parallel access, etc. So we actually store the entire memory of a smart contracts on a blockchain. We store it in an efficient way that we read only those parts of the memory which are required for particular contract execution. So if you're processing one message and it just requires a couple of variables inside the contract, it will load only these parts, these pages. And the same way, only those pages that has been modified during the execution will be persisted back into state. This kind of allows us to make the computation fast and use less resources. And also, it allows us, you know, to simplify programming for those who are doing smart contracts on Rust with us, and not only on Rust, actually, on other languages compilable to WebAssembly. Last I'm not sure if everyone familiar with such thing as a futures. So we that way support futures. This is used to wake up the contract when we receive the message reply. It can continue the execution, so it gets the state where it was like stopping and paused during the execution while sending the initial message. Oops. Yeah, so how we will deploy? First, we will launch a standalone network, solo chain, which will probably be bridged to other networks in Polkadot ecosystem and like other Cosmos chains or Ethereum. Then we will launch Kusama and Polkadot Parachain because we think that smart contracts are useful in both in Kusama and Polkadot. Since we are building on Substrate, that will be pretty easy, so not too much work on this, thanks Substrate. And why we want to use Polkadot? Well, again, not too much to sell here, but we think that it's growing community, growing support from everyone is really beneficial for us. And of course, permissionless interoperability plus shared security. So this stuff is very important. So that's why we decided to use Polkadot and build on Polkadot. What will be standalone network, Vara? So it will be asynchronous blockchain with the block in every 2 seconds. We envision that we'll launch standalone this year, like in 15 days, in proof of authority, and then switch to proof of stake like early next year and make it governance on chain. So it will be proof of stake with voting, democracy, etc. Yeah, the difference between synchronous and asynchronous programming for the blockchain. So if we take Web 2 approach, so it's like a difference between monolithic applications, old school, and new modern Web 2 cloud applications with a lot of services, microservices interacting with each other. And while like writing the monolith stuff may be initially easier because you have all the features like atomic transaction, you can create the code which is tightly coupled, can compile everything into one file, and it's maybe easier to write in the beginning, but it's much harder to scale and to maintain because like in the end it becomes a hell. So modern approach, and everyone is using it in Web 2, in cloud applications, is just in async interaction between different services. And this is actually what we supposed to be used everywhere in the blockchain, because the application logic shouldn't be that simple in the smart contracts that we see right now on chain. So it can be much more complex, more interactive. It can be different microservices which are developed and used as a common good stuff, like different oracles, whatever, any interactions, and they can be just one by one and developed by different parties. And then, since you know the interface and it's like messaging, you can reuse them. And this is a true way for evolution, for scalability, for increasing adoption of blockchain for developers. This one I will skip. Yeah, some stuff from Web 2 which Vara or Gear protocol is bringing into Web 3. So, which is like common stuff for Web 2 guys, but there is nothing like this on Web 3 yet. So different techniques for processing messages, for processing comments. It can be FIFO, LIFO. You can create a load balancer which will create like 15 or whatever amount of vectors by itself, and then use round robin, for example, to shoot the messages among them. So it's stuff like supported in different message frameworks like RabbitMQ or Azure MMQ or different service buses. This can be easily developed on Gear, and you can support like async request reply when the server, when like whatever UI or some other client sends the request to the server and then awaits, not as awaiting for the work to be completed, but continue execution, and then later, when the work will be done by a third-party service, it will ping back the initial service to continue on the logic which requires this input. So choreography, when you have like 5 services which are really independent, and you have the service number 6, which is doing orchestration between of them. So like you receive order, then you like schedule a delivery through delivery system, you make an invoice through invoice system, etc. And this service number 6, it just orchestrates the stuff which is developed independently. So guys who do delivery service work on it, guys who do invoice service work on it. So they are independent and scalable. So, and all these topics are really impossible with the synchronous way, because it will be tightly coupled, and it will be, so you cannot do it in one block, for example, yeah, so you have a limitation of one block. You cannot interact with anything outside of the blockchain, so any off-chain logic is just inaccessible in your smart contract. And with this async approach, messages, queues, you can easily access the stuff which is happening off-chain. Some unique features that Vara brings: delayed message processing and message visibility timeouts. So what it gives us, so actually it makes your program live on a blockchain. So it's not just reactive. It's not just waiting for someone who will just wake it up and say, do something. It allows the program to send delayed message to itself, and that way to wake up like one time in 10 blocks, continue some logic, then sleep. Then wake up in another 10 blocks, continue some logic, and sleep. This way, the program sleeps by itself. You can recharge, add additional gas to it, and it will be like running in a cycle itself. And that way, it can access other services or users, get the interaction from them, and live completely on chain, so without any backend stuff. Dynamic creation of child actors. It's not like the new pattern, but in like Solidity, you have to have your code compiled into initial smart contract in order to create new child contracts. And with the Gear approach, you can upload new bytecode, and master contract will receive the message about this new bytecode and will create new child actors based on a new bytecode. This way, it's like upgradable stuff. So it's really cool. Then, since we have actor processing its messages in a sequential way, but due to async stuff, we can like come into a situation where we want a block of code to be executed only once at a time. So imagine you have some code, then sending a message, awaiting reply, and another code. And due to async way of how the sync works, while you're waiting, your contract can receive another message and will bump again into the first part of the code. And in order to avoid executing it, we are supporting like critical section, mute access for secure access to critical data if it's needed. And this is like quite common stuff for Web 2 guys in parallel computing. So it's really, but wasn't like used never before in the blockchain, as far as I know. I mean, it's in contracts area. Yeah, some examples of what can be done with this. I'm not sure if you're familiar with such a toy from 90s. So it was like a toy in your pocket, some pet which can be fed by you, like you can play with it, you can heal it with some medicine, etc. And it was like evolving, growing, have some good mood, bad mood, like feel itself, happy, unhappy. And with this technology, you can create such an interactive stuff which will live in your wallet. So it can be an NFT that reacts on market price, for example. Yes, if it's above like certain threshold, it will glow. Or it can be really this Tamagotchi thing, which will ask you to feed itself, and you will reply, okay, here is some food through your wallet. So it's really interaction. It lives on blockchain itself. So eventually it will die by itself on blockchain without any off-chain logic if you're not feeding it enough. Gaming stuff. So, well, current on-chain games, like this interactivity, it's like step-by-step things. And due to this, the gameplay itself is a bit limited. And if we will use this delayed messaging mechanism and ability to ask users for their input, you can create really interactive games which will be running whole on a blockchain. You will not need the backend, which is doing different requests. The game will evolve by itself. So we have had a hackathon at Istanbul where the guys were doing the Monopoly and different developers. So they do the algorithms which were like players. And the main contract was asking each contract once in several blocks for the moves. And the game was going by itself and going through several blocks, which is like impossible in current synchronous smart contracts, where everything should be either complete in one block, or you need to ping constantly with off-chain logic or backend, whatever. Okay. Yeah, some stuff for DeFi or DEX. You can like create DEX logic on chain, so you will not need the backend stuff because of these features we provide. You can create stop loss orders, order book, and ask user about is he okay with the price or not okay, which price like he thinks will be good, and then match this in the order book and make something which is time lagged, so or biased on time, like in 5 blocks change something or close the order automatically without any off-chain backends, etc. So that's also quite nice stuff. What you can do already, so we have a portal which name is Idea, and it's like app directory, so you can upload your programs there, send some messages, explore the programs has been uploaded by other guys. You can use this portal not only for our staging testnet or for Varo or for future parachains, but you can use it for your own dev node, which you can run easily either as a binary or you can compile it. The code is also open source, so everyone can contribute or made their own fork and adopt it to whatever thing they want to. We have a separate JavaScript library for smart contract interaction, and also open source. It can be modified, forked, whatever. So come and I encourage you to just test it, try it, and if you want to contribute, you are very welcome. So we are always waiting for contribution, for feedback on it, and we are evolving it on a constant basis. Yes. That's just the QR code, which shows how to use this tool that I was showing on the previous slide to build your DAO application, like 5 to 10 minutes time. You get the template, you compile it in Gitpod, download the code, upload it through the IDE interface, and you have your own DAO on chain. So just there are some other videos also, like supply chain, dexes, etc. We have many examples. You can check and and try on your own. Some words about learning. So we are starting Gear Academy, where everyone can join, complete the course, and in the end you will create something like this Tamagotchi stuff. You can adjust it or use it as it is. So eventually, at the end of the learning, you will create an interactive game like Tamagotchi and learn all the specifics. It's video, it's like some videos, some reading materials, some tasks. So if you are a developer, welcome, join, complete, and start building on Gear. Why we are currently doing this, I mean. It's like the idea is to make like a democratization of blockchain development. Currently, we have a very tiny part of developers who are working on crypto, on a blockchain technologies. It's like really, really tiny part of all the developers. And that's due, we think that's due to domain-specific languages, to languages which you need to learn as a developer. It's quite an investment to learn something new, an investment. You need to see that it will bring you something. So it's not that easy to tell the Web2 guy, okay, come on blockchain, do something, and when they see like, okay, this Solidity or whatever else language, domain-specific, oh, it's quite complex. I need to learn something new, and I don't have time to invest in it, even for trying. And we are aiming in the group, which is like several power more, like 2 million of Rust developers, and even more like C++ guys, JavaScript guys, 20 mils, who can do programs in WASM languages, WASM compilable languages. That's really the idea, that we don't need like to fight for this tiny piece of developers who are doing like Solidity, etc. There are plenty of things to do on a blockchain, and we want and engage Web2 guys to come, try, and for this we provide the tooling they're familiar with, like this async stuff, like persistent memory and not knowing these domain-specific things, and the tooling for deploying, interaction, etc. So they can really come, start coding, and start like earning money on it. Start like showing in their own communities of how easy it is to do the blockchain stuff. So a thank you slide for the partners that we are currently working with. So we have like indexers, wallets that will support all these interactions also. We are working on, start working on different palettes with other parachains. So thank you all for the efforts that we are doing all together to, bring the Web3 to broader auditory. That's the cool stuff. And I think the more we do together, the more the ecosystem thrive, and it will be more and more democratization. We will get more and more users if it's a joint effort. So what we have also is a developer grant program. It's starting, so if you are a developer and you want to start coding, so apply. There will be grants if you develop tooling, or if you want to develop your DApp, or like some common good services which will be hosted as a smart contracts. You are welcome. We will support, not only with grant, of course, but also with some support from the coding side, from education, from marketing, etc. And if you are not developer, but just ambassador, the person who really believes in Web3 and want to spread the word, you are also welcome to official ambassador program, which is also starting soon. You can pre-apply using the Telegram or our website to communicate to our guys. from ecosystem. Some links where you can see contract templates. There are 31, as I said. GitHub for the code itself. Everything is open source, so you can fork easily, use whatever you want to, or can just contribute. You are very welcome. And small present for those who are visiting. So if you will scan this QR code with Telegram, and if you have an account in a Substrate wallet address, then you can receive this NFT on RMRK. So specially created. It's limited, so it will work for some time today, but soon it will be gone, and it's limited to 100 as far as I remember. Obvious.